we're going to be having a look at electrolysis. This is obviously non-spontaneous change, where we have to do external work on the system for oxidation and reduction to occur. It's almost where ions are forced to undergo the things that they do not want to undergo. It's the non-spontaneous, the opposite of a galvanic cell. However, reduction still happens at the cathode, same as the galvanic cell, and oxidation at the anode. These calculations are merely mole calculations with a little bit of Q equals IT and Faraday's constant thrown in for good measure. The three equations you can see there. The data booklet will give you 96,500 coulombs for 1 Faraday, which is the charge is coulombs, on 1 mole of electrons. We'll be looking at going between Q equals IT to coulombs to Faraday to moles of electrons, forwards and in a reverse direction as well. We should be able to calculate the amount produced or consumed, and also calculate the time required to produce a stated amount. To calculate the amount produced or consumed, there are 4 steps. First of all, balance the half-ion equations, then deduce the moles of electrons, calculate the moles produced or consumed, and convert the moles to mass. So a typical question, you would actually hold your hand through the question in the IB. 20 amps molten cobalt chloride. You'll be confused, there's no aqueous considerations here for 5 hours. What's the mass of cobalt and the volume of chlorine produced? So the first thing was balance my half-ion equations. 2 chlorides make 1 chlorine plus 2 electrons. Cathode, cobalt 2 plus 2 electrons makes cobalt. We don't have to go for the lowest common multiple in this situation, which you would do if it was, say, iron 3 chloride. Moles of electrons, well, Q equals IT, so Q equals I. That will give me I times T, so we've got amps times 5. It was 5 hours. Hours to minutes times 60 to seconds times 60 again is 3.6 by 10 to the 5 coulombs. How many moles of electrons is 3.6 by 10 to the 5 coulombs? Well, it must be, if the 1 mole is 96,500, it must divide it by the 96,500, which gives me 3.7 moles of electrons. How many moles will that produce? Well, for the cobalt and for the chlorine, this goes back to the moles of the electrons, because don't forget coulombs is moles of electrons. For cobalt, we had 3.7 moles over 2, which is 1.87 of cobalt. And then the chlorine, again, 3.7 moles over 2, because that was for 1 mole. That's 1.87 moles of chlorine. Convert the cobalt to mass, just times it by the atomic mass, we get 110.2. And for the chlorine, times it by 24, molar volume of the gas, roughly 21 dm cubed of chlorine. That's a lot of chlorine, but it was for 5 hours. We can also look at calculating the time required. There's an extra step in here. Can you spot it? Convert mass to moles, do the half-ion equations, moles to electrons, moles to coulombs, time required. How long does the 10 amp current flow through a solution of magnesium sulfate to produce 10 grams of magnesium? Mass to moles, well, the atomic mass of magnesium is 24.3, so it's 0.45 moles of magnesium. Half-ion equations, nice and easy. Mg2 plus 2 electrons, Mg. We want the Mg, we're not bothered about the sulfate in this case. Moles to coulombs, moles to electrons. Moles, there's 2 moles of electrons, so it's 0.9 moles of electrons. Times it by 96,500, Faraday constant, we get the charge. So moles to coulombs charge, and 86,554. Q equals IT, so solve for T, which I make 8,655 seconds, which is pretty unwieldy, or 2.4 hours. To have a look at this document, you'll find it beneath this video. Have a great day. Comment, like, subscribe at the bottom.